class. Here's 11.5, day 2. It's geometric probability today. Let's get a reminder about what probability is, and specifically geometric probability. Probability is the favorable outcomes over the total outcomes. So now when we talk about geometric probability, it's the favorable region, all of these kind of different things. In our case, we're talking about area. So it's the favorable area over the total area. So it's kind of like the area that we want divided by the total area. A couple of refreshers about probability. Probability will the probability of something happening is always between 0 and 1. 0 probability means that the outcome can never happen, and a 1 probability is where it's guaranteed to happen. All other probabilities are in between 0 and 1. Okay? So when we want to find the probability of a random dart hitting the blue sector if the radius is 5 inches long, so it's not like we're aiming at the blue section, it's just pure probability randomness that it's going to land in the blue section or the blue sector. So geometric probability says that it is the favorable area, so the area that we want, favorable over the total. So the total area of the whole circle, the area of a circle, is pi r squared. And then the area of the favorable region of the blue sector, the area of a sector, is n over 360 pi r squared. Okay? So that's our favorable divided by our total. The radius is 5, so the whole circle has a total area of pi r squared. Pi times 5 squared. That's going to be our total area. That's going to be our denominator. Our numerator is the area of the favorable region, and our blue region is our favorable region. So the 95-degree angle right here is our n. It's the amount of degrees of that sector. So 95 over 360, pi, again the radius is 5 squared. So we could find this area, and divide them, and that's going to be our answer. Notice how pi divided by pi cancels, 25 divided by 25 cancels. So really, what is the probability that it lands in the blue region? It's 95 3/60ths. We reduce this fraction, and when you reduce 95 over 360, we get 19 divided by 72, I believe. 19 divided by 72. 72. And this is what I would accept on a test. This is the exact answer. You could also round or have a decimal, maybe round to 3 decimal places here. So if you divide 19 by 72, you would get 0.264. Again, all probabilities are between 0 and 1. And so 0.26, obviously in between 0 and 1. Sometimes this is also written as a percent, so you might see 26.4% is that probability of it landing in the blue region. All right, on this one, what is the probability, again at random, that it lies in the shaded region? So the shaded region is all this gray region around here. So what I'm going to do is I'm going to find the entire square, find the triangle, subtract the two of them, and that's going to be my favorable region. So the area of the whole square, the area of the square is base times height, 16 times 16. Because this has 2 tick marks and this has 2 tick marks, they're congruent, 16 by 16. So the total area is 256. So maybe over here as well I'll have my fraction. 256 is my denominator. That is my total area. My favorable region is going to be 256 minus the triangle, right? So let's erase some of my mess up here. What is the area of the triangle? The area of the triangle is 1/2 base times height. The base is 11. It's an equilateral triangle where all sides are 11. And then the height right here, in an equilateral triangle, all of these angles are 60. And then that altitude cuts it in half, so that's 30. Here's 90. If this is 11 over here, half of it is the shortest side, so 5.5, and then my height is the square root of 3 longer. So 5.5 times the square root of 3. All right, so we take 1/2 times 11 times 5.5 root 3, and the area of our triangle is approximately, if you take 1/2 times 11 times 5.5 times root 3, you get approximately 52.39 units squared. So my favorable region is the whole square, 256, minus the triangle, which is 52.39. So when you subtract these two, then you get roughly, finding in my notes here, 256 to subtract 52.39 and then divide it by the total region, 256, you get roughly 0.795. 0.795 is our probability. Subtract these two, divide by 256, 0.795. Here's this one. Again, same instructions. At random, what's the probability that lands in the shaded region? I'm going to have the exact same strategy where I'm going to subtract this white rectangle from the entire rectangle. So the whole thing, the area of the whole shape is 6 by 13. 6 times 13 is 78. And the area of the white rectangle is 4 times 7, which is 28. So what is the favorable region over the total region? The total region is 74, the total area. The favorable is 78 minus the white, minus the 28. So 78 minus 28 is 50 over 78. We reduce this fraction, and 50 78ths reduces to 25 39ths. Or as a decimal, 0.641. Again, you should always keep in mind that your probability had better be in between 0 and 1. Last one, on the following dartboard, the radius of the bullseye is 4 inches. So here's circle A is my bullseye, and this is a 4-inch radius. And then it says that the radius of each concentric circle, so each circle out from the center circle, is 2 inches more than the circle inside it. So that means circle B would have a radius of 2 inches more than 4, 6 inches. And that means circle C would have a radius 2 inches more than B, so it would have an 8-inch radius. All right. Now it says if a person randomly throws it onto the dartboard, so they're not aiming at the bullseye necessarily, they're just randomly throwing it, what is the probability that the dart will land in region B? So my strategy is it's going to be the favorable area, which is region B, divided by the total area. Right? So the total area of the whole bullseye is this circle, pi r squared. So the area here is an 8-inch radius. So the area of the whole circle, basically the area of circle C, or that 8-inch radius, is pi 8 squared. Right? So the area of the whole thing is 64 pi. Maybe we'll just kind of have that over here. 64 pi is the area. It's my total area right here. It's going to belong in the denominator. So now my favorable region belongs in the numerator. My favorable region is just this part. So how do I find just that B section right there? Well, I would find the area of this entire circle and then subtract the bullseye circle. Subtract circle A. Okay? So I'm going to find the area of circle B and subtract the area of circle A to just get this region right here. And that's going to be my favorable region. So the area of circle A is pi 4 squared. 4 times 4 is 16, so it would be 16 pi. So now the area of B, which is what I want, that's my favorable region, is going to be pi r squared. So it would be pi 6 squared. But it's not just that. I'd have to subtract whatever A is, right? And A is 16 pi. So subtract 16 pi. That's going to be the area of circle B, which is my favorable region. So if I have 36 pi and subtract 16 pi, I get 20 pi. So that is my favorable region. That is this part right here. What did I say it was? 20 pi. So 20 pi divided by 64 pi is 20 64ths. 20 64ths reduces to 5 16ths, or as a decimal is 0.313, or 31.3%. There's geometric probability. We'll do a few more questions on that when you get to class tomorrow.